Welcome Algebra 1 to learning everything about simplifying radicals. So in this first slide, we've got the square root of 25. And the parts of the radical are, first of all, we have the radical sign. We have the number that is underneath the radical. That's called the radicand. And this very important number right here is called the index of the radical. So if no index is given, it is understood to be a square root. And lots of times we'll see the radical sign without the index. So once again, it's understood to be 2, which is a square root. So we've got one more time, the radical sign, the radicand, and the index. Those are the parts of the radical. So in this particular radical, we have an index of 3. And when the index is 3, it's called a cube root. We also have with this radical a number that is out in front. Sometimes the radical will have a coefficient. It is being multiplied to the radical. So this is 3 times the cube root of 10. This would be 5 times the square root of 6. 7 times the fourth root of x. Anytime there's a number out front, it's simply being multiplied. Simplifying a radical starts with a prime power factorization, also known as the PPF. And because prime power factorization takes a really long time to write every time, I'm just going to call it the PPF. And in order for us to get the prime power factorization, we have to start with a factor ladder. And everybody learned how to do this in pre-algebra, so we're just going to drag that skill out right now. So 150, if we're going to make a factor ladder for 150, remember we are after prime numbers, prime factors. So the first thing let's take out of 150 is 2, because 2 is a prime number. If you recall, a prime number only has 2 factors, 1 and itself. And 2 is the only even number that is prime. So 150 divided by 2 is 75. Now, 75 is no longer even, so it is not divisible by 2, but it is divisible by 3 and also by 5. If we divide it by 3, which is a nice low prime number, 75 divided by 3, think about it, it takes 3/4 to make 75 cents. 75 divided by 3 is 25. And then finally, 25 breaks down into 5 times 5. So the prime power factorization of 150 is 2 to the first, 3 to the first, and 5 squared. So 1 power of 2, 1 power of 3, but 2 powers of 5. It's called a prime power factorization because we are indicating in the prime factorization what power each of these bases are being raised to. We can also do it when we have variables. And very honestly, the variables are the easiest part of this whole operation. We're going to start again and just leave the variables. We'll deal with them last. Let's start with 2 because this is an even number. So 306 divided by 2 is 153. 6 divided by 2 is 3. 153. So now we're here. Let's see what else we've got. If you'll think back to your divisibility rules from elementary school, if we have 1 plus 5 plus 3, that's 1 plus 5 is 6, 6 plus 3 is 9. If the sum of the digits is divisible by 3, then the number must be divisible by 3. It definitely is divisible by 3. 3 goes into 153 51 times, which is still divisible by 3 because 5 plus 1 is 6. That is 3 times 17. Now we get to 17 at the bottom. You're like, well, that's kind of a bigger number, but 17 is prime. 17 only has two factors, 1 and itself. So we are ready to write our prime power factorization. I write it right down here. Now remember when I said that the variables were the easiest part? They're already written in their prime power factorization. So 2 to the first, 3 to the second, because there are 2 powers of 3, 1 power of 17, 2 powers of x, and 3 powers of y. Truly, the variables are the easiest part because we don't have to break them up. X is a prime factor, so x squared is a prime power factorization. Now, we're going to use the PPF in order to simplify a radical. And simplifying a radical is a very special form of division. That's why that sign looks a whole lot like a division sign. So, here's our radical, the square root of 60. So step 1, make a factor ladder for the radicand. Everybody needs to write down step 1 in their listening notebook. Pause the video and write it down because this is what we're going to do every time. Step 1, make a factor ladder for the radicand. So there's my factor ladder for the radicand. Remember, the radicand is the number that is underneath the radical sign. So 60 is 2 times 2 times 3 times 5. So step 2, everybody pause the video and write down step 2 because step 2 says replace the radicand with the PPF. So that's what I'm going to do. Step 2 says replace the radicand with the prime power factorization. So we have 2 powers of 2, so 2 squared. 3 to the first and 5 to the first. So step 1, make a factor ladder. Check. Step 2, replace the radicand with the PPF. Check. Step 3, everybody pause the video, write it down. Step 3, identify the index of the radical. So let's come back up here and realize that there is nothing there. Now I keep calling it the square root because remember, if the index is left blank, it is understood to be 2. So we are dealing with a square root. We have identified the index of the radical. There you go, step 3. Step 4, divide the powers by the index of the radical. So pause the video and write down step 4 right now in your listening notebook. So step 4, divide the powers by the index. This is what I mean. Each one of these bases has a power. The second power, the first power, the first power. We are going to take each one of those powers and we are going to divide those powers by the index of the radical. The bases 2, 3, and 5, they will not change. Here is what I mean. So one more time, step 4, divide the powers by the index. So 2 divided by 2. I'm not talking about the radicand, the base 2. I'm talking about the power that I have circled. 2 divided by 2, one whole time. 1 power of 2 is coming out. 2. Is 1 divisible by 2? No. So 2 won't go into 1. Therefore, the 3 to the first has to stay under. We do it again with the 5. 1 divided by 2. 2 won't go into 1. So the 5 to the first power has to stay under. We're only going to be able to take out even powers. That's it. So what do we have that remains? 2 times, remember, this is now a coefficient of the radical, 3 times 5 is 15. So the square root of 60 simplifies to 2 times the square root of 15. We're going to do it again, and we're going to follow the 4 steps that you wrote in your listening notebook. So step number 1, make a factor ladder for the radicand. 48 divided by 2 is 24. 24 divided by 2 is 12. 12 divided by 2 is 6. 6 divided by 2 is 3. Step 2, replace the radicand with the prime power factorization. Note the powers of 2. 1, 2, 3, 4. There are 4 powers of 2, and there is only 1 power of 3. The next step is to identify the radical or the index of the radical. The index of the radical, remember, if none is given, it is understood to be 2. So we have used a factor ladder, we have replaced the radicand with the prime power factorization, and now we have identified the index. We're now going to divide the powers by the index of the radical. So 4 divided by 2, 2 times, none left under. 1 divided by 2 won't go. The 3 has to stay under. So what remains? Let's simplify it. 2 squared is 4, and underneath the radical is 3. So once again, this had an even exponent. That is why a power of 2 is allowed to come out. Once again, the bases pretty much never change until we simplify at the very end. Let's go on to number 2. And step 1, make a factor ladder for 270. So 270 divided by 2, that is 135. And 135 is divisible by 1 plus 3 is 4. 4 plus 5 is 9. Yes, it is divisible by 3. It is 3 times 45, and then 45 is divisible by 5, and that's 9, and then 3, and then 3. So this is our factor ladder. That's step 1. Go back to the radical and replace the radicand with the prime power factorization. So we've got 1 power of 2. We have 3 powers of 3. And then we have 1 power of 5. So step 1, make the factor ladder. Step 2, replace the radicand with its PPF, with its prime power factorization. Step 3, identify the index of the radical. This radical is a cube root because it has an index of 3. Next step, divide each of the powers by the index of the radical. So here goes. 3 goes into 1, no times. That is why 2 to the first shall remain underneath. 3 goes into 3, 1 whole time. None left under. Will 3 go into 1? No. The 5 remains under. So the cube root of 70, simplified, is 3 cube root 10. 4 steps, same procedure, over and over. The steps work no matter what the index or the radicand. The steps are the same. So let's finish this one. This is a 4th root of 32, a to the 4th, b to the 6th, and that, of course, is c to the 1st. Remember my hint at the beginning. The variables truly are the easy part. So step 1, make a factor ladder for the radicand. Don't worry about the variables, just deal with 32. So 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. So 32 is 2 to the 1, 2, 3, 4, 5. 2 to the 5th power is what 32 is equal to. Step 4, replace that 32 with 2 to the 5th. A to the fourth, B to the sixth, and C to the first. Last step, what's our index? Our index is 4, and our powers are 5, 4, 6, and 1. So from here, divide the powers by the index of the radical. That procedure does not change. 4 goes into 5 one whole time. Think about it. 5 divided by 4, one whole time, remainder 1. That's what's happening. So whatever is whole is going to come outside of the radical, and whatever remains stays under the radical. So 4 goes into 5 one whole time with 1 power of 2 left under. 4 goes into 4 one whole time. The variables truly are the easy part. 4 goes into 6 one whole time, but this time, think about it, 6 divided by 4 is 1 remainder 2. So 4 goes into 6 one whole time, but there will be 2 powers of B left underneath. And will 4 go into 1? Nope, the C stays under. Lastly, simplify here. Just get rid of all those 1 powers because we don't need them. 2AB, 4th root, 2B squared C. And that is our simplified radical.